Hey guys, welcome to part 5 of this OTV module. So in the previous section, we had a look at OTV unicast configuration, and in this section, we are going to take a look at how to build up the redundancy here. So we are going to bring up the secondary router of the site green and site yellow, and we will see that how we can make the redundant configuration work here. So if we talk about the topology briefly, this is what we have. So we configured CSR 11 and we also configured CSR 21. Now we are going to configure CSR 12 and CSR 22, and we will see how the load balancing happening between the VLANs. In my case, CSR 12 and 22, they are not configured for OTV yet. So I will need to configure the OTV, and this time I'll configure directly for the unicast mode. All right, so at this point here, if you try to reach between the two end hosts, I should be able to reach because I do have connectivity between one of the routers from each side. Let me go to CSR 12 and let me check the configuration of what I have. This is the LAN side configuration. This is the outside interface configuration, gigabit 1. Yeah, and this is the LAN side configuration. So the first thing I do is, since I need to extend VLAN 11 and VLAN 22, let me configure the LAN side interface with the bridge domain for VLAN 11, VLAN 22. After that, I will also need to configure a side VLAN, which I already configured on the CSR 11. So if you can see here, show run interface gig 2. This is the configuration we have, which is side VLAN. I need to do the same configuration. So I will copy and I will paste it to gigabit 2. Okay, so this is the configuration we have there in the LAN side interface. Now on the other side, which is gigabit 1, I do not need to configure anything specifically because this is already being advertised in the WSPF. Let me make sure I can reach the other routers, other OTV routers, 100.1.11.11. I can reach it. Same thing for 21.21. This is the IP address 21, show IP. Sorry, 100.2, the IP address 100.2, 21.21, and then 22.22. This is for the secondary router of site number 2. So I do have reachability between all the OTV sites from this router. So what I'm going to do is I'm going to configure the overlay configuration, and let's see how it goes from there. So the first thing, OTV join interface. The join interface would be the interface which is facing the outside interface, which is facing the other OTV routers. In this case, this is going to be my gigabit 1. Then I'm going to configure OTV. This is going to be my OTV adjacency server, and then unicast only, because this is also going to be my secondary adjacency server. Then I'm going to configure OTV use adjacency server, and then the public IP address, the primary IP address would be the CSR 11, which is 100.1.11.11. So let me put it there. And then I need to put the secondary IP address, which is my IP address 100.1.12.12, and unicast only. Now, you also need to configure bridge domain service instance. So because you need to extend that. So if you do a service instance 11 Ethernet encapsulation.1q11, and this is going to be bridge domain 11. Similarly for service instance 22 for encapsulation.1q22 and bridge domain 22. If you do a show spanning tree, VLAN 11, spanning tree mode PVST, okay, let me make sure that my side VLAN is also there. Okay, we'll wait for this to be moving to the forwarding state. And if you do oval interface, this is shut down right now. I do have the join interface. I do have the adjacency server configured. I have configured this as a secondary one, and I do have the breach domain configured here as well. So pretty much that's all we need. If we compare with the configuration that we have on the other side, yeah, that's all we need. Let me try to bring up the oval interface now, and let's see. Okay, so at this point of time, if I go to CSR 11 and if I do a show OTV VLAN, it is going to be active for both the VLANs. Now, if the redundancy work fine, then we are expecting the one of the VLAN to move to the other CSR for the active role. So in that case, either of 11 or 22 or the even VLAN, they would be this guy CSR 11 will be the active forwarder for, and the CSR 12 will be the active forwarder for the other VLAN. So let's see if the OTV adjacency is coming up or not. Okay, it has not come up yet. Is there anything wrong? IGMP version 3. Okay, I think OTV site VLAN I have not defined. OTV site identifier. I need to specify these things. OTV site identifier, and the OTV site identifier has to match with what you have in the same site. So in this case, if I do this, it says the OTV site identifier is 0001. It has to be the same value here, and also the OTV site VLAN. Let me see if I configured this at any place. No, I did not. Yeah, so OTV site breach domain 11. This is something also I need to configure. So these two things is what you need here. One is the site breach domain. This is the site VLAN, and then the site identifier. The site VLAN and the site identifier, it has to be the same value for both the routers in the same site, and it should be different for the different sites. Now you can see that I have adjacency up. If I do a show OTV adjacency, it shows that I can see both of them. I can see the router which is in the same site, which is CSR 11. I can also see the same other router, CSR 21, which is in different site. But if I do a show OTV, it shows that it is not forward capable, it is not ready, and it is not the AED server. If you do show OTV VLAN, it is inactive for both, and still CSR 11, if you do a show OTV VLAN, this is still active for both of them. Now let's wait for a few minutes, as we need to do, as you have seen from the previous videos, that we need to wait for 3 to 4 minutes after doing a no shot on the OTV interface for the control plane to be built. So we will wait for the time, and after that we will see how it is converging. I'm going to pause the recording for a few minutes and I'll come back. All right, I waited for about 2 to 3 minutes. So now if I do a show OTV output on the CSR12, you can see that it is now forward capable. It says I'm forward ready. And it also says that I'm the backup AD server, even though I'm not the AD server, but I'm the backup. And then it says I am AD capable, right? If you look at this now, show OTV VLAN, you can see that now it is active for VLAN 22 and inactive for VLAN 11. If we go to CSR 11, I'm expecting to see the opposite. It is going to be active for VLAN 11 and not for VLAN 22. If you go here, so you can see that it is active for VLAN 11 and it is inactive for VLAN 22. So essentially this is being load balanced now. For the VLAN 11 traffic, the CSR 11 is going to be the active forwarder, and for VLAN 22, the CSR 12 is going to be the active forwarder. Now if we want to test the connectivity, if we do ping 192.168, sorry, 123.11.11 2, this is for VLAN 11, I still have the connectivity. And if I do 22.2, which is for VLAN 22, I still have the reachability. If you do a show OTV route, bridge domain 11, you can see it is there. If you do the same thing for 22, you will see that it is not being learned anymore. It will be gone, because if you do here, show OTV bridge domain 11, show OTV route bridge domain 22, you can see that now it is being learned here. And if you do this, if you do the same thing for 11 here, it is not being learned. So basically, all these MAC addresses, what you are seeing here, this is going to be the forwarding router for VLAN 22, and this is going to be the forwarding router for VLAN 11. So if I do a OTV site, now OTV site, now it is able to see the other router in the OTV site, which is 11 and 12. It says that both of them, the MAC address, the system ID, the AD enabled. And if you do show OTV, it says that, okay, this is how it is, right? Here, if you do a show OTV on CSR 21, so it says, yeah, I think this is fine. If you do a show OTV route for bridge domain 11 and bridge domain 22, so yeah, I do have reachability at this point of time, from VLAN 11 to VLAN 11 and then VLAN 22 to VLAN 22. So I think this is working as expected, as we expect to. What we need to do now is we need to configure similarly the CSR 22 as well. Here also, if you do a show run interface gigabit 2, the external interface is configured, and you can see I can reach 1.11.11, I can reach 12.12, and I can also reach 2.21.21. So I have the external reachability, but I have not configured the LAN cell interface, or I have not configured anything for the OTV specific configuration here. So if you do a show run interface gigabit 1, this is basically the LAN phasing interface, which is this side here. I need to configure that here on CSR 22. So I'm gonna do is I go to CSR 21, I will see what configuration I have there. I'll just simply copy and paste it. This is basically I'm gonna extend VLAN 11.22, and also I need to configure the side VLAN, which is 222 on the LAN phasing interface. So if I do interface gig 1 and then this configuration, no shut, that's all I need for the LAN phasing interface, spanning tree mode PVST. After that, I will need to configure OTV site identifier, and the site identifier is going to be the same as we have here. If we do a section OTV, this is the site identifier, which is 0000002, and then the bridge ID, which is site bridge domain. These two parameters, they need to match between the two routers in the same site. So I'm going to configure the same thing here. After that, I will go to configure, I'm going to configure interface overlay 1, OTV join interface. This is going to be gigabit 2. Then OTV use adjacency server, and the configuration would be, I can put it here, it should be 100.1.11.11, this is the primary, and then 100.1.12.12, this is the secondary, unicast only. And then bridge domain I need to define, which is service instance 11 Ethernet, encapsulation .1Q11, bridge domain 11. Similarly, service instance 22 Ethernet, encapsulation 22, and bridge domain 22. I need a no shut. Okay. So this is configured 111.12 unicast mode, and you can see that all my 3 adjacency came up. The reason why it is 3, because from this router perspective, it is 1 CSR 21, 1 for CSR 11, 1 for CSR 12. So total 3 adjacency what I could see. If I do a show OTV adjacency, you can see everything there. If I do a show OTV site, As of now, it is not ready. So if I do a show OTV, this is still not forward capable. The control plane is being built. So again, we need to wait for a couple of minutes before we can move forward. So let me pause the recording again for 2 to 3 minutes. We'll come back. All right, so we're back. Now this is completely converged. If you do a show OTV on CSR22, which we just configured, you can see that the forward capable is yes, this is forward ready. This is the backup AD server, and then it says that this is AD capable, and it is detecting that who is my adjacency server, primary and the secondary. Okay, so now if you do a show OTV VLAN, it shows that I'm active for VLAN 22 and I'm inactive for VLAN 11. And if we go to CSR 21, it will tell the opposite, which is I'm active for VLAN 11 and I am inactive for VLAN 22. So this is to make sure the bridging loop doesn't happen. Only one of them in the side is the forwarder. And that's the reason, even if you are not forwarding the spanning tree packets over the OTV, you are still able to manage the bridging loop. I mean, you are still able to prevent the bridging loop. So now if you do show OTV route here for bridge domain 22, you should be able to see everything. And I want to make sure that when you are trying to reach these two IP addresses, 11.2 and 22.2, you are still able to make it. Let me clear the ARP 192.123.11.2 and similarly for 22.2. Let me try to ping. Yep, I can reach it, and the same thing for 22 as well. Yes, I can reach it. So I have the complete reachability at this point of time across the sites. Let me do a right mem everywhere. Okay, so the configuration is now saved. What I'm gonna do next is show. All right, here, do I have a default gateway? I have. Okay. Now, one thing is in this topology, my switches in between, which is the core switch here, you can see core switch 22, 21. These are running HSRP, and similarly in the site 1, core switch 2 and core switch 1, 11 and 12, they are running HSRP. Now, by default, the OTV here, it is going to forward all the HSRP packets across generally. So you do not want your site to have to not have the HSRP active locally present on your site. You always want it to be locally present. If it is not, then if you have a client in VLAN 11 and client in VLAN 22 who are trying to talk to each other within the same site, they will need to go all the way to the different site because the gateway will be on the other side, and then it will need to come back, which will add latency, and this is not a good way, optimized way of the design. So what you want is you want to make sure that HSRP active and standby it is elected within the site, and you are preventing the HSRP packets to go from one site to the other site by through the OTV cloud. So that way you make sure that this election is happening locally. Now, in ASR in the ASR iOS XE, the ISIS by default is it makes sure that your some of your OTV ISIS packets are not basically being advertised, right? For related to the HSRP, but we still need to make some additional changes. We need to make some configuration changes. What we will do is we will apply a filter. We will apply a VLAN filter in this MAC access group filter in the LAN interface of all these routers, which is gigabit 2 here on site 1 and gigabit 1 here on site number 2, just to make sure that my HSRP is locally present all the time. So the configuration that we have is look like, let me put it here. This is my CSR 11. This is how the configuration looks like. So if you do a show run section MAC access list, I'm basically denying anything which is the source of my HSRP group address. It could be any group. The same thing for VRRP and same thing for GLBP. In this case, I'm using HSRP. I did not need to use VRRP and GLBP, but to make it more generic, you basically want to make sure you deny any packets coming with a source MAC of those HSRP MAC addresses. You just do not want them to be forwarded over the OTV. You want to stop right there in the LAN interface. So what you will do for that is now you need to apply this filter under the bridge domain. So you will go to interface. In my case, this is gigabit 2. So I'll go to interface gigabit 2, service instance 11 Ethernet, and then you will need to apply this filter, MAC access group, and then you put this filter, which is OTV filter FHRP in, right? Similarly, you do the same thing for 22 as well and apply the same filter. That's all you need to do. Now the same configuration I will be applying on all these routers. Okay. And after that, I will need to apply this command. If I do a show run interface gig 2, I will copy this and I will configure it here. Similarly for 21, it would be gig 1. And for 22, it will also be gig 1. All right. So now this is configured. At this point of time, if I now make the host site to, let's say I'm going to make it as only VLAN 22. So I'm gonna change the default gateway, no IP default gateway 1124, and instead I'm going to configure 22.22.54. Okay, so what I'm doing is I'm making this host set site 2 as in VLAN 22, and I'm configuring a default gateway for that. And on host number site 1, I'm configuring VLAN 11, and I have configured a gateway for this in VLAN 11. Okay, so at this point of time, if everything works fine, I would expect the VLAN 11 and VLAN 22 to work across the OTV site. So here I have VLAN 11 in the site number 1, and then I have VLAN 22 here in the site number 2. I'm going to ping through that. Now, if you look at the HSRP thing, it would always be pointing to the local MAC address. This is 11.254. If you go to CS11, if you do a show OTV route for bridge domain 11, you can see that I'm no longer. So here it says that it is AC0B. This is your HSRP. So why I'm learning it still now? Maybe it needs to be cleared. Clear OTV route. No, what I want is if I run this command here on 12, this is for bridge domain 22. Here I'm not learning anything for HSRP, which is good. If I run this command, show TV route bridge domain 11, and I do 22. Okay, let's see how it goes. So we'll try to ping 192.123.22.2. You can see that now I can ping it across the site. So if I do a show IP CEF 192, I'm going to ping it with the source of my Ethernet Okay, I'm gonna ping that 192.123.22.2 with a source of Ethernet 00, and this is going to be my routed packet. So if I do a trace route for 192.123.22.2 with a source of 192.123.11.1, you can see that I'm reaching there directly here, and slowly it will be edged out because we have prevented this from being learned. I should not be able to learn it on the LAN interface. Okay, so at this point of time, we do have reachability and across the site in the two different VLANs, and also we have configured the filtering. So for the filtering, you need to do some additional step when you do it on the Nexus, but when you do it on the iOS XE, a lot of things are already pre-built in the ISIS. The only thing you do is you apply a MAC access list on the LAN phasing interface to prevent any traffic coming with the source MAC of the FHRP active MAC address. So if we again do a show run interface gigabit 1, which is gigabit 2, sorry, this is this guy, show run interface gigabit 2. This is your LAN interface. You applied this filter of MAC access list, and then if you do a show MAC access list, you put this one, show MAC, show access list, you put this filter, you can see that it is denying this traffic which is coming from the LAN interface. Okay, so that's pretty much all we have to cover here. One thing we can talk about is some of the commands, like what are the useful commands. To summarize it, mostly these are the commands you need. One is show OTV, and you run show OTV site to make sure that you can see the other peer of you in the same site, if any. If you did not have another router in the same site, you will not see anyone else. You do a show OTV VLAN. This is to make sure that which VLANs this router is the active forwarder for. And after that, you do a show OTV route. You can specify the bridge domain specifically if you want to filter it out. And then if you want to do a show OTV adjacency, you should be able to see all the OTV routers in your cloud in this particular table. So those are pretty useful commands which you want to use for troubleshooting. And again, one thing I wanted to reiterate: make sure that you do have your M2 size taken care of in the underlay, because OTV is going to add the extra piece of shim on your actual data packet. So if your application is trying to send a packet size of 1500 and OTV is trying to add on top of it, then it might not be passed through the network if your network underlying infrastructure doesn't have more than that in size of M2 permitted. So make sure that it is taken care of. All right. The last piece we want to configure is a packet tracer. So what do you want to do? How do you want to capture the packet in the OTV site router? So what we can do, let's say that in the CSR11, our packet is coming from show run interface gig 2. This is coming on gigabit 2. So what I can do is I will configure an access list, IP access list, let's say 101 permit, okay, extended 101 permit ICMP. The source address is 11.1, okay, and the destination is going to be 22.2. Let's capture just one side, that's fine. Now I will do debug IPv4 condition, sorry, debug platform condition IPv4. You basically do interface also. I want to capture on the interface, which is gigabit 2, and then you can configure an access list. The name of the access list is 101, and you want to filter at the ingress. You do a debug platform condition start, right? So this is now started. You also configure a few things, say for example debug platform packet trace. You can do packet, no, debug platform, packet trace, packet count, you might be, let's say 1,000 packet, and FIA trace. So FIA trace is going to tell you all the lookups. So FIA trace, what it means is this option performs a trace of your additional packet path data information. What it means essentially is this option performs an FIA trace. Once it is enabled, then you can view some of the additional information when the packet is being parsed on your router. So it is enabled detailed via the FIA trace. You can increase that. And is there anything else needed? Debug platform condition, sorry, debug platform packet trace start statistics. It would be debug platform condition start. Then now we can look at show platform packet trace statistics, and we can send some traffic. Let's say this ping this, and what are we doing in the packet trace? Show debug. We have a packet trace condition gigabit Ethernet 2, and the IPv4 ACL show access list 101, host 192.123.11.1 and going to 22.2. This is what I'm trying to do, and it says the matching ingress interface gigabit 2. So let me stop it, and if I want to do show platform packet trace summary, I don't see anything. Okay, it's not seeing the packets. Let me see what I'm doing wrong. The direction is the ingress, which is fine, and I'm doing it on the router 11, which should be the active forwarder for VLAN 11. Maybe since the routing is being done locally by the LAN side router, it is not going to this router. It is actually going to the other router, CSR 12. Maybe what I will do, I will receive the return packet on this guy. So if I change the condition, which is debug platform condition ingress egress, I will do both. Okay. And I'm gonna do current IP access list extended 101 permit ICMP host. I'm going to allow the reverse path as well, which is 192.123.22.2 to 192.123.11.1. Okay, so now if I do debug platform conditions start, and if I do a ping, and I also do a trace route, let's see if we see something. No. Well, the traffic is basically when it is going from site 1 to site 2. Since the routing is being done by the core switch in between, this is going to be hitting here on this interface. So let me try to configure the same debug here. So if I do IP access list extended 101 permit ICMP host, let me permit ICMP any, and if I do debug platform condition interface gigabit 2 and IPv4 access list 101 ingress debug platform condition start, debug platform condition packet. Okay, start and show platform statistics. If we now do show platform packet trace statistics, let's try to reach this guy again. Something is wrong. What we are missing? Maybe when I do debug platform and then condition interface gigabit 2, you know what I'm missing is the EFP ID, because my traffic is not going to hit the actual interface, it is going to hit the service instance of it, because this is doing .1 queue. So the EFP ID, it would be it would be 22. And now if I do IPv4 access list 101 both, now it should work. So if I do debug platform condition start, and now if I do the ping and the trace route, if I now do a statistics, now you can see I have got 5 packets matched. So if I do a show platform and then packet trace summary, you can see these are the packets I have seen. If you want to look at the packet number, which is show platform packet trace, and if you want to look at the packet in detail, so you can do packet number 1 and then you can do decode, and now you can see the complete output. So this is what you are seeing is the feature. This is because of the FIH trace. This is exactly how the packet is being parsed internally. You don't need to worry about all these things unless you need to really drill down. But what is important is you see the path trace, you see the input IP address, the ingress IP address, the egress IP address, the source, the destination, 11.1, 20.2. This is the ICMP packet, and this is coming on gigabit 2 EFP22, and the state is forward. So if this was being dropped, you would have seen something else, but this is what you want to see. This is being forwarded. So you can see that this is a pretty useful tool. All we have done is access list we have created. In this case, I have permitted anything, but you can do your access list, doesn't matter. And then if I do a show debug, then I have configured an access list on IPv4 access list on gigabit 2.efp22, because my traffic is, whenever it is hitting here, it is already being routed to VLAN 22. Now if I wanted to do it here, if I do show debug on CSR 11, you can see I applied this access list ingress interface, show access list 101. What I need to do is IP access list extended 101 permit ICMP host 192.123.11.1 to host 192.123.22.2, and also for 11.2. Okay. If I do that, now this traffic should be seen here. The only difference is I also need to apply this in the gigabit Ethernet EFP instance. So I need to do debug platform conditions and then interface gigabit 2 EFP 11 IPv4 access list 101. It should be ingress. Now if I do condition start, and if I do the ping in the layer 2, which is 192.123.11.2, I should be able to capture these packets here. Show platform packet trace statistics, and if you do a summary, and if you do a detail, let's say packet number 2 in detail decode, you can see this is the packet I'm seeing. So this is pretty useful tool. You can use it for capturing the packets to on the box itself, and this is very useful for troubleshooting. So having said that, and if you want to undebug, you can do undebug all. Okay, it's not gone. So you need to actually do debug platform condition stop, and you need to undebug platform packet trace interface. Condition. Okay, how do I clear everything? Debug platform condition clear. Debug platform clear. Clear platform condition all. Okay, so now my debugs are all cleared. Yes, now this is the command I need to run. Clear platform condition all. Okay, let me save the configuration. So now all the debugs are removed, but this is very easy tool to use. Please leverage that. And that being said, that brings us to the end of this whole module of OTV. So if we can summarize it, what we have seen is we had a look at the overview of the OTV in the first session, the basic overflow workflow. Then we took a look at the OTV underlay configuration, the multicast, the unicast configuration. We took a look at the OTV in the multicast mode. We took a look at the OTV in the unicast mode. Then we did some FHRP filtering just to make sure we can localize the HSRP active and standby within the site. And then we had a look at the summary of the commands, the verification commands, and then the packet tracer tool, which is very important to troubleshoot the problem at times. So thank you very much for watching. I really appreciate that. If you have anything in your mind, if you have anything to comment on, please comment on it, and I'll go through that. Thank you so much for your time. Thank you. Take care.